I want to start off this morning a little bit meta, and I want us to think about why we're here. We come to conferences for a lot of different reasons, and they're all legitimate reasons. There's no wrong reason to come to a conference. Well, maybe if we brainstorm, we could come up with some wrong reasons. But some of us come because we have friends here and we want to hang out with friends that we don't get to see regularly, and that's cool. Some of us come here because we're marketing our products, and that's cool too. And I want to give a big thank you to our sponsors, particularly Constant Contact, who brought us coffee this morning. And some of us come here because we want to learn, and some of us come because we want to be known, or we want to market ourselves. But I really want to talk about learning, really, to start off with. And there's a lot of different ways to learn. And some of the ways that you might learn is in a lecture hall like this, maybe back in college. Some of the ways that you might learn is to watch a podcast, to watch a screencast, or to watch another conference talk on video somewhere. Maybe the way that you learn is to read things. Maybe the way that you learn is to talk about it with your friends, or to put your hands on it. For me, I think about learning is really to do things. I can listen, I can read, I can do all these different things. But until I get my hands in it, and the phrase "use it in anger," I don't really understand it until I can really play with it. And so for me, the best way to learn is to do things, and the best way to do things and learn is to have fun doing it. And if you're just like slogging through the stuff, that's not cool at all. So what I want to talk to us about today is really a playground for learning how to do things. And there's been a lot of talks this weekend that I think are germane to what I'm going to talk about today with distributed computing and with doing big data analysis and all this kind of predictive machine learning kind of stuff. I think all that stuff is germane. And I don't know about you guys, but listening to Brian this morning talk, and also to Chris talking about distributed, all of those things are inspiring to me, and I want to do something with it. And so what do? All right, this is my kind of nerdy secret. I play EVE Online, which is this massively multiplayer game where we blow spaceships up on the internet. And it's really nerdy. I'm not going to try and deny that at all. It is definitely a nerdy activity. I'm not really a gamer. I enjoy playing board games. I played last night. I think based on my EVE experience, we played Resistance last night, which is a game where you lie to your friends, and that's right up my alley. I don't have an Xbox at home. I don't have a PlayStation at home. The only game I have installed on my computer and my phone and my iPad is EVE. So what are we going to talk about here today? I want to talk about a couple things. I want to start off and kind of defend my nerddom and tell you that it's okay to play EVE because it's really cool. And so we're going to talk a little bit about the background behind EVE and what makes it unique from other games that you may have played. And then I want to talk about market analytics, because that's what's in the title. And we're going to spend maybe it might seem a little tedious at first, but I really want to lay some of the groundwork for how EVE in particular implements its economy and its market, and then in general some of the concepts of how commodities or market or stock trading works. And then finally, because we're here at a Ruby conference, I'll put some code up as well. So one of the things that really turns me on about EVE Online is that there is one universe. If you played World of Warcraft, or if you played the original Ultima Online, or really EverQuest, or really any of these massively multiplayer games, what they do is their infrastructure can't handle their player base. And so they shard their player base. And that term, sharding, which is really interesting, is it's being used, like MongoDB uses this term, and a lot of the NoSQL use this term, sharding. It actually came from Ultima Online, was the first place that it was used in '96, that they couldn't handle their player base. And so they originally had this one world, and the response to it was so fantastic that they made up this lore within the game that Ultima Online lived within a crystal that got shattered into these multiple shards. And so then you would have these different shards. And when you would log into the game, that you would log in and you would select which shard, like it might be US East or US West or PAC Rim or EU or whatever. And if you didn't choose the same server that your friends chose, then you couldn't play with them. That they were doing their thing, you were doing your thing. You'd build up your character and all this kind of stuff. But then you weren't like able to share any of that with them. Eve is not like that. Eve is one universe, and that's really phenomenal to think about. They have this distributed node network where each of their systems are typically on clusters of nodes and their infrastructure, and then they'll have super nodes that they'll come in and use on really hot systems. But when you log into Eve, you log into Eve. And there's about, like I've got the numbers up here, there's about 500,000 accounts right now, and when you log in, it tells you how many active players are online. And at any given time, there's somewhere between 30 and 60,000 people in the same universe. Think about that for a minute. That's pretty fantastic. So what we're seeing here in the background of this image, and I'm going to zoom in on it with a really low quality image, this is kind of a well-known representation of space, and I've zoomed in. Each of these dots represents a solar system. And there are jump gates between all these things, and so you can travel through space using faster than light travel. But that's the scale of what we're talking about. Each of these dots represents at least one sun, a number of planets that are around it, and there's activity that happens within each of these dots. And from the last slide, there's several thousands of these things. These are highlighted in different colors. Can I get a glass of water? I probably should have done that before I started. These are highlighted in different colors. The green is kind of in the center, and the red is on the outside. This has to do with security status. Eve is a notorious sandbox, which is kind of anything goes. There's a few small rules that you can't violate, which I'll talk about in a minute. And when you violate some of those rules in the green space, then thank you very much. I appreciate that. In the green space, there are non-player character police that show up and pop your ship, and you're done. In the red space, there's no such thing. And in the yellow space, the police may or may not show up based on where you are in that space, and they may show up late. So there's this varying degrees of safety, but what I want to kind of impress to you is that there's really no safety anywhere in Eve. Even though the police show up in the green space, and so one of the things that you can't do is there's theoretically no non-consensual PvP in high-sec space. And if you shoot at someone, then literally instantly the police will show up and pop your ship. They have infinite damage and they have infinite resist. There's no way to kill the cops. There's no way to survive the cops. And if you do, then it's considered an exploit and your account is banned. So, the one thing about CCP is if they think that you're breaking their very few rules, then your account is banned. And there's not a lot of what would you call that, appeals to that process. They won't even tell you why they think. They just said, you broke the rules, you're done. So Eve has this, even though that this is in this, and this is kind of what I want to say about there's no safe space. So even though this policing mechanism happens, there's different ways of thinking about how your ship can apply damage to other ships. There's a sustained overtime damage, which is what most of us think about in terms of damage per second. And so a battle is often won or lost based upon how much damage your ship can sustain over time and how much it can put out over time. But in high-sec, they have what they call ganking, which is you take a bunch of ships that they shoot volleys of weapons, and so your damage per second is calculated based on your rate of fire and how much damage each volley does. So your initial volley is the alpha strike, and if you have a high enough alpha strike, you can kill their ship, and then the police show up and kill your ship, and then your buddies come along and loot all the wrecks. That's completely legitimate. That is a legitimate play style. You're not exploiting the system at all, And EVE is this kind of world that fosters that kind of stuff. It fosters that creativity and how to take advantage of fellow players. PvP happens in all aspects of the game. It happens in the manufacturing space, it happens in the marketing space, and it definitely happens out in space. So what kinds of PvP, besides that, what kinds of PvP might you expect? There's some fairly famous examples. A few months ago, there was, actually, where's my speaker notes? That's what I want to see. I can't even see my speaker notes, so I'm trying to make this up as I go along. All right, so I'm going to just continue to make these numbers up. There was a battle that happened in low-sec space, and there's these large, the cost, and we'll talk about this in a minute, the cost of ships varies quite wildly. And this one guy had this extremely expensive, fairly rare ship, and he literally had a right-click menu that said, choose this option and we win, and choose this option and oh shit. And he chose the oh shit option and put his ship someplace it shouldn't have been. And there's this concept of the bat phone, that out of game, that you have these groups of people who are playing together in corporations. And when something happens, then you start texting everybody, get in game now. And this huge battle of over 3,000 players in one battle just fell on this guy, and he's like, hey, I need help, somebody come help me. And his friends came in, and it just escalated and escalated to be one of the largest battles in EVE's history. There was over 2,000 ships were destroyed, and over 3,000 players were involved. And that was pretty amazing, and it was all over this, I right-clicked and hit the wrong menu option. After that, there was another battle a couple months later, which was part of an ongoing war. You can own space, and you can actually, as a player, have sovereignty over solar systems. And there are resources in those solar systems that you want, and there are wars fought over those resources. One of the largest alliances in the game, the Goon Swarms, were attacking an alliance that was primarily based on the Reddit community called Test Alliance, Please Ignore. And Test had these moons that people wanted, and the goons wanted it, and so they mounted everything they had to go take those spaces. This is actually it looks staged. This is an actual screenshot of that battle. There are over 4,000 players in this battle, and almost that many ships were destroyed. And so you think, well, how does that happen? Well, people come in, lose a ship, re-ship up, and get back into the fight. And so when this kind of stuff happens, when you can try to imagine 4,000 people in the same battle, EVE uses this thing, which is kind of fascinating. And I don't want to talk too much about their infrastructure, but they have what they call this time dilation, which they slow the game clock down to allow their servers to keep up with all the activity that's happening. And so something that would normally take 20 seconds, if you're running at 50% tie-dye, then it would take 40 seconds. And one of the comments from this battle was, boy, you know tie-dye is bad when you found out your ship blew up on Twitter first. So this is actual screenshots from game. And so I'm using a lot of, EVE is beautiful, and it is brutal, and we joke that EVE is real largely because it has real consequences. When you lose a ship, it's gone. There's no, hey, save my stuff for me, I'll get back to it. All losses are real losses. And so you pay in-game currency to purchase items, and when they're destroyed, they're destroyed. So when you're sitting here on this jump gate, getting ready to jump from high sec to low sec, and there's somebody there, you know somebody's there, you've got this feeling in your gut of real risk. I'm about to jump. Am I going to die or am I going to live? I don't know, but I'm going to hit the jump button anyway. All right, so player versus player, there's all these ships in battles. Let's talk a little bit about those ships. You're not really meant to understand what all this stuff is. I'm just trying to show you diversity. So there's different classes of spaceships that's similar to a Navy. And then there's different roles that they play based on that. Within each of these categories, you see 4 columns. And as it goes down, there's some similarity in the background color of what those images are. In EVE, there are 4 races which are derived from humans, and each race tends to have their own ships of each class and role. So what you end up with in EVE is about 200, maybe 200 plus ships that exist in game, unique hulls. Now, each of those hulls actually can have different fittings applied to them. And so this one you see there's guns up in top, and there's some electronic warfare on the side and defenses on the bottom. And then they show you over here on the side, there's all these calculations about what the DPS is and what the effective hit points of the systems is. It tells you about how fast it is and all kinds of fun stuff. So the main question is, how do you fund this? How do you keep buying ships if you keep losing them? Well, there's 3 different ways. You can kill things, you can find things, or you can sell things. There's lots of ways that you can kill things in game. You can kill non-player characters and get bounties. They also drop things that you would want. You can kill players in the game, and sometimes they have bounties, and sometimes they drop things that you want. There's actually sanctioned wars between the 4 races, and when you engage in those sanctioned wars, then you get rewards for doing that when you win battles. You can find things, and what that means is there's a whole industry around mining, and there's mining of asteroids for resources, there's mining of moons for resources, there's collecting resources from planets, and taking these things and combining them into a very large industry segment that then you can turn around and sell in the market. So this is what all that's background. Here I am. I'm like 20 minutes into my talk, and we're just now getting to some of the interesting bits. EVE has a player-driven economy, and that is the bedrock of the whole game. And what do I mean when I say player-driven economy? What I mean is when you buy something, there is about a 90 to 95% probability that you're buying it from another player in the game. And when you sell something, there is a 90 to a 95% probability that you're selling it to someone in the game. Now, how did I come up with that number? There's like 20,000 items in the game. And about 10% of those items are items that non-player characters buy and trade. The other 90% of the items are only available from other player characters. Now, what items are those? They're ships, they're weapons, they're guns, all of that kind of stuff. The stuff that you actually want to use to play the game are all player-driven items. The stuff that you don't care about as much, things like trade goods. You can buy, cows and dirt and, water and things that you might think about would be part of the lore of doing space exploration. Those things are the things that the non-player characters trade. So this whole economy is based upon players finding things and selling them to other players and buying them from other players. And this economy is so vital to the whole system that they hired this guy. His name is, I can't pronounce his first name, Goodmanson. He has a PhD actually from University of Rhode Island in economics, and he is their chief economist at CCP. CCP is a company that manufactures EVE. He's not the only economist, he's the chief economist. They have 3 economists on staff whose job it is to analyze the economy in game and make sure that it doesn't crash. So they do iterative releases. They do releases like several times a year. And that release process has to go through the economist to make sure that the changes in the game aren't going to crash the economy. Well, they sometimes pre-announce some of the features, and when they do that, so the value of items is based on supply and demand. And so when they have an item like a given ship, and it has certain performance characteristics, and people are used to the way that ship performs, and they say, this ship is this popular based on how I know it will perform, then a new release comes out, and they do something like add an extra damage bonus to the ship, and now this ship is more popular. And when they announce that that's going to happen, there's speculation on buying up those ships so that when the release comes out, they can sell them at a higher price. That's the kind of economy that we're talking about. So let's jump in here and take a look. I hope that this is visible. Can everybody see this pretty well? This is a pretty nice projector. I'm sorry that it's negative text and really fine. I don't have any control over the colors of really the way that the text are rendered there. But anyway, I just wanted to show this here. That this over here is the item browser, and it has a hierarchy of all the things in game. And you can browse through that. There's also a search thing up there. This over here this is a market book. And so when you think about market trading, you have people who have a thing and want to sell it, and you have people who don't have a thing and want to buy it. So there's two different types of orders. There's a market order and a limit order, and this is just straight up market exchanges. This is the same way that commodities markets work. This is the same way that stock market works. This is the whole thing. If I wanted to buy this Dramiel ship, I could just go right out and pay 53 million ISK, that's the in-game currency, and it's mine. Great. If I want one, or if I have one and I want to sell it, I can turn right around and sell it to this guy for 50 million. And he'll buy it, and I have the cash, and I move on. That's a liquid market. As an immediate market transaction happens. So that's one way that things work. There's also, here's another item. This is concentrated Veldspar, which is one of the ores that's extracted from asteroids. And what I want to highlight here is this. In the other example that I showed you, the buy price, which is the top sell order, was higher than the buy price, which means that there was a positive spread. In this case, I can go buy something for 13 ISK and turn around and sell it for 1402. And this guy up here has 1,250 of those things. And if I were to go over there and buy that and turn around and sell it, I would make a profit on that. The thing to note is it shows the jumps column over there. That item is 7 jumps away. So this is one of the ways that you can make money in the game. Everything, even though it's a virtual economy, it has a virtual location. And sometimes people are standing in this location and want this thing, and it's over there, and they don't want to go get it. And they're lazy, just like we are in the real world. And so what you do is you say, I'm industrious. I'll go over there and I'll buy that thing, and I'll fly it over here to you, and I'll sell it to you, and I'll make a profit on it. That's just called hauling, really. And these guys who enjoy the game are space truckers. And they have spaceships that are really large and massive, and they're slow. But they can carry these things because all these items have mass that they take up, so that their cargo bay may be 50,000 M3 or squared meters cubed. 50,000 meters cubed. And so they can hold so much stuff, fly it over here and sell it and make a profit on it. So let's throw in some maths up here. These are pretty basic formulas. I don't really have to go over a lot of this stuff. There is a tax on every transaction that happens. The joke is Eve is real. Somebody has to pay taxes. Profit is revenue minus cost. And so when you think about revenue, this is if I sold this thing, that's how much money I would make it. The cost is really how much I bought this thing for plus my taxes. And then the markup, and this is kind of the funny one. I don't know if you've ever dealt with economic web applications or stuff. The difference between margin and markup is subtle, and a lot of people mess that up. What I'm trying to say here is that if you know how much your profit is, based on how much money I'm putting into this, my cost, how much more am I gonna make? Which is what I'm calling the markup there. All right, here's another item that I want to look at here. This is the Geristus Molnar rocket. And what you can see here is that there's pretty good spread between these two. And that's another term I'm going to throw at you. The spread is the difference between the maximum buy price and the minimum sell price. And so what you can see here is if I turn right around, if I'm a trader, if I turn right around and I bought all 19,640 of these, if those were my orders, and I bought them and they were all fulfilled at that price, and then I turned right around and sold it at the minimum sell price, then I'd make pretty good bank. It's about 12 million ISK, and that's not a bad trade. All right, here's an aside into the real world. This is called a candlestick graph. It's really fantastic, and interestingly enough, it is really old. The Japanese have been using this since the 1800s, and we started using it not long after that. What this is showing you here is that each of these represents a day of trading. There's an open price and a close price. There's the high value. So if you look at these shadows, or sometimes they're called the tails, that's the high value and that's the low value. The color coding tells you if it was a bear or a bull day. And so you can look at this and see the trend pretty fast. And each of these things, there's lots of names for these individual things. There's a soldier, there's a hammer, there's the hangman, there's a shooting star, there's all these esoteric names. There's tons of books on how to interpret candlestick graphs. What does Eve give us? Eve doesn't give us that. Eve gives us something similar. One of the differences between Eve and the real world is there's no market open or closed. The market's open 24 hours a day. There's a downtime every day that happens, and I think it's like 8:30 Eastern time. But the game is played by people all around the world. And so there's no open and close. It's a global market. The downtime is considered open and closed, but Eve doesn't help us out. And I don't know how well that you can see this, but right there I'm highlighting a single day. It has that dot is the average price of the item that was traded that day, and there's a very faint tail or shadow on both of them that shows the high and the low. The green line there is a 30-day moving average. The red line is a 5-day moving average, and across the bottom is the actual trade volume. So let's look at this guy again. And there was a pretty good spread on his prices in terms of his buy and his sell. But when you look at the history, almost everything is happening right at the bottom, which is where the buy price was. So a lot of people are buying these rockets, but not many of them are selling them. So this is a risky item. So and maybe to make this more clear, my role in Eve is as what I call a station trader. I don't undock from the station. I sit in station, and all I do is I buy things and sell things, buy things and sell things. I help ease the market in terms of liquidity. This is a risky item to buy because it would be hard to unload it. So let's look at a different item. This is a different type of ammunition, and what you see here is the average prices have a nice spread between them, that they're actually selling and they're actually getting bought. Although I will note that most of the buying at this low price happened a while back, and now they're mostly selling at a high price. So part of the whole game of being a station trader is finding these items that are not as risky to sell, that you can buy at a low price and that you'll be able to turn around and sell and not get stuck with the inventory and be able to sell it for a profit. So here's another view of this same data. Eve gives us this history data which shows the daily low and the daily high and the daily average. It also shows us this quantity here of how many were actually traded on that day. So if we go back and look at what the spread looks like on this particular item, the spread's pretty good. The profit is almost 800 per item, and that means the margin is pretty close to 200%. That's not bad. That's probably a pretty good item to trade. So let's talk a little bit about data, because this is where we are, and I'm starting to run out of time, and I'm starting to panic a little bit. Eve provides lots of data out of game, and that's what makes this fascinating to us as programmers. All this stuff is fun, and all this stuff is really interesting, but it's also kind of, station trading can be hard. You don't want to wade through all that stuff. You want to actually get at the stuff. So Eve provides a couple different things. They have a static dump of all of their static data, and we'll talk about that in just a second. There's an API to fetch some of this data, and then there's some other nefarious things you can do. This is an example from a schema RB of one of the tables that comes from the static dump. There's about 80 tables worth of data. They store it in not in MySQL, in Microsoft SQL, MS SQL, however you pronounce that. And the community turns around and reformats that Microsoft SQL into a usable database format. And there are about, like I said, about 80 tables. There's all kinds of interesting stuff in here. They have all of the solar system, the map of all the systems with XYZ coordinates, so you can plot your own three-dimensional graphs of all the systems. They have a list of where all the jump gates are, so you can do your own out-of-game routing of how to get from one solar system to another. This is really cool stuff. About 500 meg worth of data uncompressed loaded into a database. So I turned around and did some just straight up active record-y stuff on it. Of course, they don't like our conventions, and so you have to do some active record-y kind of playing with setting table names and primary keys and foreign keys, but that's really no big deal. That's pretty easy to do. And then you can do normal Rails stuff after that. You can set up your associations. You can set up scopes. You can do all that kind of stuff. That's cool. So there's a full API as well. Unfortunately, it's really poorly documented. In fact, the community is the one that manages all the documentations for the API because CCP themselves just barely support it. And so here's this site for Eve Development Network, and if you go in and look at the API reference, you'll find things like this is a list of there's about 75 different API calls that exist, which is not a small API. This is all based on things that you can do with characters. So you have things like this research. What do you have in research, or your skill queue? Or there's this interesting one, which is obviously highlighted in purple there, for market orders. So as a trader, what I can do is I can make an API call with my character and say, what orders do I have on the market? And here's this stuff that comes out of it. I turned around, and it's pretty easy to use Faraday to write a wrapper around it. And what I have is this API fetchable method, and you basically give it its endpoint, and you give it an active record database with all the attributes that were on that documentation page. And then I've implemented this method called fetch, which basically uses Faraday to make the request and then turn around and parse it and just do an update attribute, shove everything into the database. Really easy. I can turn around new API calls in like 15 minutes. All right, so all of this stuff is really based on your own personal character data. It's not getting at the whole market. So how do we get at the whole market? Because what we want to be able to do, or what I want to be able to do, is go through and find out what are good items to trade, because I want to make money. So as it turns out that when you make a market request, that request is actually cached on your local disk. Interesting. And it did not take too long before the cache format was reverse engineered. The EULA is very specific, and they're very serious about this end-user license agreement. The EULA is very specific about writing bots in game, or writing, machines that do things for us. It says you can't do anything with a bot that would be faster than what you could do it as a human. And really, you're not supposed to do anything that manipulates the in-game client. But the cache is outside of the client. So there's this really gray area. And they came out with the EULA, and you don't have to read all this, but really what it comes down to is they say, hey, we know you're scraping the cache, and we don't like it. But we're not going to ban you for scraping the cache. It would be like a secondary offense. It's like I can't pull you over for not wearing your seatbelt, but if you are pulled over and you're not wearing your seatbelt, you'll get a ticket, which is kind of silly. They published this, and there was a huge uproar because we've been cache scraping for a long time. And so then they came out on the forums, and this guy is one of the Eve developers, and he says, okay, we know that we said that we weren't going to do anything about cache scraping, and we're really not, but we can't change our language because the lawyers won't let us. So here's this website called Eve Central. Eve Central is really the original collection of market data, and I'm really running out of time, so I'm getting close. Eve Central, and they collected all this data. They were the ones who figured out how to parse the cache. They were the ones who actually provided clients to you that you could download that would sit and monitor your cache file so that as you made market queries, it would upload the data to them. So this is a community aggregation of all of the market data. So this went on for a while using their own custom stuff, and eventually other people wanted to participate, so they set up what's called the Eve Market Data Relay. And this is where I really got turned on. Because Eve Central has an API, but it's cumbersome and it's rate limited, and they're not just going to give you a copy of their whole database. But the Eve Market Data Relay is a 0MQ network with 4 or 5 different nodes that instead of the data being uploaded directly to Eve Central, it goes into this 0MQ network that you can become a subscriber for. And you can literally drink from the fire hose and get every market query that any player is doing in the game in near real time. That's fantastic. That's like, you talk about big data, that's big data. You can basically take the largest virtual economy, and put it on your hard drive. That's fantastic. So they have this JSON format here of how the data comes through, and I don't really want to dwell on this too much, but it's just JSON. It's easy to parse. And what I did is I set up a 0MQ client in Ruby, and he's not complicated. You connect to him. You have a list of the relays, and you can get some redundancy in your relays, and then here's this little loop. He says this received data is a 0MQ call that receives it, dupes my string value because he's going to turn around and update it on the next message. And then I process that message, and I take it and I shove it in the database. And so I'm taking all these messages and I'm shoving them in the database so that I can do my own analysis on it. Now, as it turns out, if you're running a MacBook Air and you are drinking from the fire hose and you leave it on overnight, it's going to fill up your hard disk and you're going to have a bad time. I ended up having to be pretty rigorous about pruning my data, of taking stale data and making sure it was cleaned out. This system, these are system stats. I ended up having to set up a DigitalOcean instance. My goal was to have a system that was hosted, that I didn't have to run on my MacBook Air, that was constantly collecting data, so at any time I could go in and I could figure out what the right items to buy and sell were. And so this system's been up for a while. You can see he's got about 1 gig worth of database size. He's processing about 200 messages a minute. That's low. I know that I'm dropping messages on the ground. I'm doing this in Ruby. It's single-threaded. I have a single worker. And because I'm doing database pruning and stuff, I haven't yet figured out the stuff that Chris was talking about with Bloom to do all that stuff asynchronously. And so I know that I'm dropping messages on the ground, but I'm getting a ton of really good data. So what am I going to do with that data? I just throw it in the table, of course. The joke about Eve is that it's spreadsheets in space, and that's not far off the truth. What I'm calculating here is this is the minimum sell order, the maximum buy order, and I calculate the markup. This average quantity takes that table of data that I showed you that had the history of stuff, and it just averages what those orders were for any given day. And then I calculate the spread, and I have this other number called the velocity over here, and I thought it would turn out to be really important. The velocity I defined, and I don't know what this really is in economics, the velocity I defined as the spread times the average quantity. So that would kind of give me a hint of how much money was moving for that item on a given day. Turns out that's not really very interesting at all. What really is interesting is the average quantity, because the spread on some items was so huge, but they were only trading like once a month. What I needed to find was items that traded not too small and not too high. If there's a big trade on it, if there's a lot of quantity, then that means there's a lot of competition. So I'm trying to find right in the sweet spot. And that kind of comes back to some of the things Brian was talking about, machine learning. What makes a good item to trade? That's really interesting. So I'm going to try and run through this. I see Johnny over there. I see the gong's about to ring. I'm going to run through. This is kind of how we play it in game. Here's the market on this side. This is a list of my orders over here. So here's the market over here showing all the buy and the sell orders. Here's my list of orders. Here's a tiny window showing what my current inventory is. What you can see here is one of my orders for blue ice is shown over here in the book as blue. And you can see that I'm down the list, fourth. That means that if somebody wants to go complete a market transaction for blue ice and buy it, he's not going to buy mine. He's going to buy that other guy's. So here's what I'm going to do. I'm going to come over here. I'm going to modify the order, which I'm going to set my price to be 1 penny less than his. So I'm still not like giving away profit, but I'm coming in under him. And then what you see is I pop up here on the top of the list. Now this is also really fantastic. I can load in-game. There's a web browser built in-game based on WebKit 3. It's really old and it's really terrible, but it's there. And CCP provides JavaScript functions to interact with the client. So this little button right here, if I click that button, it actually performs a market lookup for that item. So I have in my browser my list of items that I think are really interesting. I can click the market lookup. It looks it up for me. I can verify that the data is correct and decide whether to trade it or not. And that, is just straight up. There's just some JavaScript that happens on there. So I'm concluding, Johnny. What do we have here? What we have here is CCP provides lots of data about the static state of the universe. They provide an API for you to find out things about your character, and then there's this other side channel of scraping out the market data and being able to consume that fairly easily with Ruby, and then you can do whatever you want to and then come into the browser, and you have these JavaScript calls that can then interact with the client. It's end-to-end collecting everything you need to know to be a stock trader in Eve. And it's really interesting stuff. This is a great playground that if you're looking for some way to experiment with big data, if you're looking for some way to experiment with distributed computing, if you're looking for some way to experiment with market trading algorithms, which is where I started from, this is a great place to play. And a lot of other economists are playing in this because, like I said, it is the largest virtual economy. All right, I'm done. My name's Doug. I work for Gaslight.